Wouldn't it be wonderful? Wouldn't it be wonderful if customer service assistants not only apologized for not understanding our questions, but if they actually took steps to understand our problem and then took actions to work towards a resolution, and actually a resolution for that problem. Today, I'm going to tell you a history of how LLMs have moved from passive text generators to active problem solvers. And whether you're a business leader, a developer, an AI developer, or an architect, you'll walk away with key insights of how these systems work and key things to pay attention to make agents that actually work in the real world. I'm Stephen Hibbert. I'm a senior prototype architect at Amazon Web Services, where I've worked with dozens of customers, helping them to make agent systems work in the real world. I'm joined by my colleague Diana and Matt from Trainline, and together we're going to talk about how tool use works, otherwise known as function calling, a real deep dive into how that works. Diana is then going to talk about how agents work, and then Matt is going to tell us how Trainline put this into production with a multi-agent architecture in their customer service assistant. So, I want to start this presentation with a motivating example. A little bit of the why. Why do we need agents and tool use in the first place? And I want to do that by telling a brief LLM history of answering the following question. What's the weather like in London right now? So in the beginning, there was only text. So if you went to a chatbot interface, something like Claude.ai or the Amazon Bedrock Playground, and if you asked this question, you might get a polite response. Something like, I'm really sorry, I don't have that kind of information. You'll have to go and check your weather app on your phone, which is fair enough. And the reason for this is that the LLM realizes that it doesn't have access to real-time API information, and so it can't answer this question. It might actually be able to recall what the weather was like on some day in history, say December the 12th, 1992. But because it wasn't trained 10 seconds ago, there's really no way it can know what the weather is right now. And for a little while, we were stuck on this problem. And what we really need was a way to let the models read from and write to the outside world. And that's where function calling, otherwise known as tool use, really began. So what we can do, and we wouldn't ever quite do it this way in the chat interface, but I've done it here to illustrate the point. We can tell the model that it has access to a set of tools. And it can use those tools to help answer a user query. So now, when we ask the question, what is the weather in London right now, the model will assess if any of those functions are relevant to help answering the user query. And it might call then one of them, or maybe many of them, and then use the actual answers when we go away and execute those functions in traditional software and return those answers. We can use those return values, those answers, to generate a final response. So here we can see in London right now, it's 21 degrees and sunny, a lovely spring day. That's scarily accurate. I did this presentation over a month ago. So let's have a look at where this came from. So back in 2022, it was commonly said that LLMs were bad at maths. And so you might ask yourself, can an LLM answer a question like, what is 100 plus 100? Well, one paper that explored this was the Miracle Systems paper. And what the authors did was they created a data set, a fine-tuning data set of simple one-digit mathematical arithmetic. So questions like, what is 5 plus 3? And what they then did was tested an LLM's ability to answer two-digit arithmetic questions, and then 3, 4, 5-digit arithmetic questions. And they found that for two-digit arithmetic, the model maintained 100% accuracy. But then that dropped to just 9.3% for answering 5-digit addition arithmetic. And what this acutely demonstrates is the failure of an LLM-only system to generalize very far beyond the types of data it's seen in its training distribution. The authors went on to show that by introducing a neurosymbolic architecture, they were able to combine the LLM with a symbolic calculator to actually run the calculation. So we're using an LLM to extract and classify the entities, and then a symbolic calculator to actually run the mathematical calculation. So moving on to how, just like we did in our weather example, we can formulate this prompt, give it access to a calculator function, and LLMs are fantastic classifiers. So choosing the right tool for the job is a classification problem. LLMs are also really good at entity extraction and recognition and understanding a natural language query. So by combining these LLMs, so the LLM is a deep neural network. This is the neuro part of the neurosymbolic architecture. By combining the LLM with the symbolic discrete Python function, we create this hybrid architecture that gives us the best of both worlds. We're able then to solve 9-digit and beyond arithmetic and create much more robust AI systems. So, problem solved? Well, now we need to consider a few new problems. So there's the potential for hallucinations, where the model makes up tools that it didn't really ever have access to. We have the problem of the potential for increased security risk because we're running code execution. We also have to think about the verbosity of the input and the output text and how much of that we want to show to our users. And we might have parsing problems when we're trying to actually extract and run that code in software. So if you're in this room, I suspect you've probably been building with LLMs a little bit. And many of you will have started in the logical place. If you've tried to add real-time capabilities, maybe you've tried to augment models with your information, or maybe you've run into a knowledge gap in the models where you needed to augment its capabilities, like with a calculate example. And you might have been developing tools with AI frameworks like LangChain, Pydantic AI, Bedrock Agents, or the Anthropic Tools API. A very logical place as a developer-friendly tool that abstracts away the actual mechanics of how tool use works. And what I want to do for the next few minutes is peel back this abstraction and show you exactly what is happening. And when I do that, one, I think you'll realize it's simpler than you think. And two, you'll realize why it's important to write great specs for your tools, just like you'd write great documentation for your developers. So this is what tool use actually looks like. And it's actually quite simple. So we start by defining a function calling syntax and a list of available functions. We then combine this with a user prompt, which has got something about the task the user's interested in, the user's question. We pass these both to the model, and then we generate a completion. We then look at the model response and see if it contains a function call. If it does, we parse out the function call and actually execute it in our application in traditional software. So on the client side, on the server side, wherever that is. Then, when that function's finished executing, we'll take the return value and pass it back to the model, along with all of the prior context, so the model knows what's going on. And then we continue this loop until our response doesn't contain a function call, which will take to mean the model is done, and we'll pass the final response back to the user. So let's dive into each of these steps in even more detail. So the first thing I said we needed was a function calling syntax. I've shown that here in XML tags. This could be XML, but it could also be anything you can later parse out in software. The next thing we have is a list of available functions. I've only actually got one function here, and I'm specifying it using JSON schema, but you could use any specification that is interpretable by the model. Next, we need a user message. What's the user actually asking? So here I'm asking, I'm in Austin today. Do I need a coat? And if you've used the completions API, something like the Bedrock Converse API before, you'll know that you can have a system prompt and a user prompt. Here, I've got my syntax and my functions in the system prompt, and then I'm using the user prompt for my user's question. Now, we put these together, and we hit the API to generate a completion, and we get a response. This is what the response might look like. You can see it's respecting our function calling syntax in the function call XML tags, and it's making a prediction that we should hit the getWeather function with arguments of city Austin and state Texas. When we passed the API, when we called the API, we also passed a stop sequence parameter. So LLMs are trained on a default set of stop sequences, which are special tokens which are output when the model is finished generating. But you, as the caller, can actually add additional stop sequences. And we can do this because we know the syntax of function calling, so we know it will always end in end function calls. So we know that anytime that finishes, we should interrupt the model. And this is really important because if you don't interrupt the model here, it will happily go on and hallucinate a response because LLMs are next token prediction machines. So we need to reliably have a way of interrupting the model when it predicts it needs to do a function call. So here we are. We've stopped sampling from the model, paused execution, and now we need to check. Does this actually definitely contain a function call? So we can do a simple check, something like this. If stop reason is stop sequence, and the stop sequence is the one we defined in the API call, then great. It's almost certain that this contains a function call. So we parse that out, and we execute it. So I've skipped the parsing for now, but here's what our function might look like. It's a getWeather function, which calls an API, and then returns a formatted string as a response. So I haven't shown it here, but it's very common if you're using a LLM tool or an agent framework that in Python, they will actually parse out the doc string of the function and use that as the description for your function. And that's really, really important that that's accurate and descriptive, because that's how the LLM is going to be able to discriminate between many functions, and it's a really key thing to get right. This function as a whole is really key to implement. So this would be your retrieval function if you were doing RAG. And it might be a code execution function if you were doing a coding agent. Here it's hitting a real-time API for weather. And you can see the return value is a Python formatted string. And this is done as a good practice because that's going to be more interpretable by the model if it's in natural language. It's not critical to do that, but really think about what you're returning from these functions when you're designing them. OK, so we've executed that function, and we've returned a nice string with the weather information. So now we're going to pass that back into the model with the prior context. And we're going to do that by actually building up the messages array that you can use from the conversation APIs that you'll be familiar with. So here you can see I've added that additional response to the assistant message. And we're actually extending the same assistant message that we previously paused execution for. And we found that actually leads to much, much better accuracy and results than putting that into a user message, for example. So if your messages list ends with an assistant message, we'll actually go ahead and start resampling from the same assistant message. OK, so now we're going to, now we've got this response, we're going to generate another completion. In this case, the model realizes it's got enough information to answer the question, and so it generates a normal string. It's not a function call. We're going to go ahead and check if that contains a function call in our XML syntax. In this case, clearly no. So we can go ahead and return that to the user. OK, so that is function calling. That is how it works. You are now all fully trained experts in that. Now I want to say what has that got to do with agents? So agents are emerging in production as key capabilities in LLMs get better and better. And agents are systems which can engage in reasoning, make a plan, reliably execute tools, and recover from errors in their environment. And although the use cases for agents may be complex and sophisticated, their implementation is actually quite simple. Typically, they're an LLM call which has access to run tools in a loop and then iterate on the response in their environment. And that's really why it's so crucial to design these tools with thought and clarity. So with that, I'm going to hand over to Diana to tell you a little bit more about the agent landscape and how we think about those.
Hello, everyone. He gave you kind of a sneak peek into what I'm about to talk about. If function calling is really so powerful, because it is, right? And thank you, Stephen, for that explanation. That was really detailed. Then why do we even need agents? What are agents about? And I'm guessing that if you've been here the whole day, you've heard agents a bit. Have you asked yourself, maybe you're even asking yourself right now, what is an agent? Can you confidently say you know and can define what an agent is right now? And the answer is likely no. It's a very hot topic, but everyone has a different way of thinking about agents, a different framework, a different frame of mind in how to classify them and how to think about them. I'm going to share one with you. And when I say one it's not the one, right? It's one. It might be wrong in your eyes, or it might be different, but it's one way of thinking about that. So when we think about agents, and in this chart, the idea is for you to think about agents in a spectrum. And the spectrum goes from agency to effect. So when I'm talking about agency is the autonomy and the decision-making power that an agent has. Can it actually decide, use the reasoning to take action, or does it already know prescriptively what to do? And then the effect that it has in its environment. Is it reading and writing? Is it doing any specific action? And we will explore 3 cases. The first one will be one end of the spectrum, which is what some people may call just input-output. There are schools of thought out there in the industry that think this is an agent because it's doing something for you. And on the other hand, a completely autonomous agent. And somewhere in the middle of the spectrum of what honestly I see most with customers when I talk to them about how they're thinking about agents, how they want to start with agents, and the use cases they want to explore. So the first one, and I'm using Stephen flow intentionally. When you look at the flow of function calling, it's like a free flow, right? It's deciding, do I need to use another call? Do I need to use another call? And iterating on them, right? So if we look in the first end of the spectrum, which is I don't have any agency and I don't have any effect over my environment, which in the chart is called radical, right? I don't have any agency, and it's basically input-output. So I basically have one message, I send it to the model, I get a response. One end of the spectrum. In the middle, we have some effect on my environment and some decision-making power. And again, this is where we see most of the use cases at the moment. It's really similar with a very predefined workflow. So if you see it as, if you're familiar with step functions or similar things, I sometimes like to say like a smart step function in a way. So you have a message or a request or an action that is passed through, and then there's some actions that are predefined that the agent can select from. And then in here, right, there's a human in the middle for evaluation, and then the response is sent back. So again, some action, some agency, some effect. And then we have the other one, which is pure agency and pure effect. What everyone likes to think of as an agent, and what you might identify as an agent that everyone might be talking about, which is like a virtual employee, right? Someone that just knows what to do, does everything for you, will replace employees with this agent. Where a lot of customers think they want to be or they are, but no one, or what everyone thinks that others are, but no one really is the truth, right? So there are a few reasons why this is the end of the spectrum. It has more complexity. The more you move from one side to the other, the more complexity you're faced with, especially when you're moving into production, right? So the sky is the limit. You can get it to do loops into autonomy and decision making and reasoning. And how does this really happen? It happens in iterations, right? When we think about even a year ago, I don't know if we ever were thinking about agents or talking about agents, right? We could get LLMs to do one thing reliably and correctly. Then now they can do multiple actions, like I said, the middle, reliably, maybe select from a few actions, perform a few actions reliably. And then in 6 months, they're maybe already there, but the goalpost keeps moving, right? We say maybe we're already there. Maybe the agents or the LLMs can perform complex actions or a series of complex actions reliably now. But then we introduce more complexity into what agents can do. That's actually shifting every 3 or 4 months, like how complex they are. So the goalpost keeps moving. And I want you to think about one keyword here, and that is reliably. Can LLMs and agents do what you ask them to do? Yes. Can they reliably do it? And that is one of the main questions that I try to help customers with. How can we evaluate them? Would I get this in front of my customers and be okay with it? And that is one of the key things about agent implementation. So how can we put this together in function calling and agents? And one way to look at it is with Bedrock agents, right? And again, this kind of puts what Stephen was talking about before and what I was just mentioning, meaning you would have an agent, and the agent has access to not only tools, but also information. And in this case, is signaled as or presented as knowledge bases. You might know it as retrieval augmented generation, which is RAG, and is basically context that the agent might need, additional information that it may add to the response. And as Stephen was also saying, the tool definition is very important because it would allow the agent to be very specific about what it needs to choose and when it's reasoning through the request. And that is really what makes the difference between an agent and tool calling. So, two very frequent patterns of orchestration for agents. The first one is React. And many of you probably have read about React, which is what is instilled into the LLMs at training time, which is reasoning and action, like thinking about what they're doing and then actioning. So basically you have a request, you go through the tools in the flow that Stephen was showing, the model does actually, and then the next action to execute, and it iterates through it, right? Do I need another one? Do I need another one? But it's thinking, right? And then the other one is reason without observation, rewould. And the difference between this and the other one is that it already knows what the end goal is, right? So in the prior one, it iterates. In this one, it already knows what the final result needs to be. So it can create a plan. And in that plan, it can send the actions needed to execute the plan. So these are just general meta orchestration plans, and how can you put them together in a cohesive way? You can either do it on your own, and you can also use a multi-agent collaboration, which is a pattern that's emerging. And again, and I encourage you, if you haven't been to that session today on multi-agent collaboration, to take a look at the recording. It goes in detail into all of the different patterns that you can follow for putting agents to work together in parallel with supervisors, etc. But the idea is that Bedrock as a platform can help you set this up. And the way that it does that really is in a very easy way help the agents execute and most importantly communicate with each other, right? You can have supervisor agents, but you can also have agents that work together in tandem. So multi-agent collaboration is really about observability, about security, and about multi-agent communication. And again, you can do that easily with Bedrock. Now, what does this actually mean for you in terms of should I go React, should I go Reboot, does it even matter, like which pattern I choose? And this is what that multi-agent collaboration boils down to. And is one, like React, goes in iteration, so it would take longer to iterate through tasks. So if latency is a concern for you, then that is a trade-off. Reboot is more brittle. Model upgrades, right? You're sending on one plan, one action, and execution. And you also have less freedom to change the plan. Or maybe it would take more work if you want to change the plan, right? So what does it mean in terms of function calling? When you are talking about function calling and some of the tools that the LLMs will use when you're using function calling directly from the large language models, they can be very generic tools, like a calculator, like a code interpreter, like a database call, something very specific, simple syntax. And then you can also define your own APIs. And I'm super excited that Matt is almost coming up, and he's going to share a little bit about what Trainline has done. And this is where the power is, right? LLMs can help you do many great things, but they can do even more when you give them access to your data. Your data is the power. Your microservices and the APIs that you develop are really the power. So specific tools like a data API or your own API. So function calling is really for standardized syntax, for simple actions. You cannot really overload function calling on an LLM because they would get confused, as Steven was saying. When you need reasoning, when you need agency, autonomy, decision-making, planning, that's when the agents come in. So automation of work and complexity of processes is what really sets apart function calling from agents. And I actually see customers use both. You can use them together. You don't have to choose. You can use one or the other for different tasks, and you can use them together. But it's important to really understand when and how to use them so that you don't over-engineer and go down the agent route by default, which I see customers do a lot. And it does have its complexities, so be sure that you're using the right tool for the right need that you have. And with that, there is some more on Amazon Bedrock agents and our repo. But if you want to go and see some of the samples on patterns for agents and try them out on your own. But to see how all this comes together, as I was saying, and I couldn't hold myself back, and I mentioned it a little bit. Matt is coming in from Trainline to tell us how they're using function calling and agents on their amazing travel assistant. Thank you.
Hi everyone, what a great talk so far. We've learned about function calling, we've learned about agents. Now we're going to learn about how we applied it at Trainline, rolled out a multi-agent system to over 2 million users and counting. I'm Matt Farrelly, I'm head of machine learning at Trainline, and we're going to tell you how we built the Trainline assistant. So Trainline's massive. I'm sure you've all heard of us. We're the largest rail app in Europe. We have over 6 billion annual net ticket sales, and we are active in over 45 countries. As we grow, as we scale, we're an ambitious business. How do we scale our customer support? So what we do is we support our customers throughout the life cycle when they travel, from searching to buying to traveling, and then finally the aftercare as well. So we want to keep this very high quality of customer support as we grow to above 100 million users. So how do we do that without just continuously hiring more and more support agents? How do we cover this wide range of things that customers might ask? If they're searching, they might wonder what their options are. They might think about, how can I balance costs? If I book this cheap ticket, is it going to be comfortable enough for my 5-hour journey? Split save, what's split save? How does it save me money? Do I have to change train when on my split point? Is my train delayed? Can I bring my cat onto the train? Can I bring my dog Rufus onto the train? How does the delay and repay work? This is quite complex stuff. And it wouldn't have been possible to build something that could manage all of this automatically until now. So we built the Trainline Assistant. The idea behind the assistant is simple. We want to give it access to tools to be able to reason, and this implies also a multi-agent system. But we also want it to be able to hand over to humans when it realizes it's out of its depth. We don't want to reduce the level of customer support that we give to our customers. In fact, we want to make it better with this. So this isn't actually about cost saving, it's about retention, it's about making our product better. So we approached designing this with a couple of principles in mind. And we wanted to stick to really a microservice approach, really. And that's from a separation of concerns from an agent point of view. So we wanted kind of these specialist agents to work together, but also from a service design. So a lot of the time, people kind of build these monolithic services and they put multiple agents, especially if they're using something like LangGraph, it's tempting to do. But actually, that is very limiting because it means it becomes quite complex and designing for evaluation is difficult. So we wanted to adopt this microservice approach. This allowed us to design for evaluation. It made sure our system was scalable and extendable. We could add new capabilities. And in fact, I'll talk about one in a sec that we just added recently within 2 weeks. And it would minimize our integration effort when we needed to integrate other APIs. So let's give a quick overview of the system. So we've got an interface in the app. It's actually in the My Tickets page for those of you that are familiar with the Trainline app. When a customer types a question into the app, it goes into the orchestrator. The orchestrator, so this at this level is a service. We're talking about services at the moment. So inside this is an agent, and we'll go a bit more in depth in a second. But it has access to terms and conditions tool, refund agent, information retrieval service, and also is integrated with customer support tools. So from a user point of view, if they're handed over, it's seamless. It's in the same chat. You're going from speaking to an assistant to a human. So how does this work? What's inside each of these services? So you have tools, right? And each of those boxes, for example, refund agent, actually to the orchestrator, it's a tool, but it can be an agent itself and also have its own tools. Inside each one is a state graph. It's an evaluation pipeline, and there's long and short-term memory so that each agent can remember, what the user has said, but also potentially have access to other information as well. So let's look inside the orchestrator. So this is a sort of high-level representation of the state graph. We built this using LangGraph as well as several Bedrock services. So let's take an example maybe. Can I travel with my dog? So it would first go through guardrails in. Now the guardrails in, we're actually using Bedrock guardrails at the moment. Works very, very well. If it passes the toxicity checks, we're checking that they're not prompt attacking us, etc., then it will go to the supervisor. And this is a kind of typical supervisor pattern, essentially, in that it has access to these tools. It decides which route to go down. So in this case, which one could it go down? Probably information retrieval. It could be terms and conditions, but actually the orchestrator might reason that actually it's a bit of a general question for terms and conditions. And actually, it wants to access Trainline's general knowledge base. Great. And then that goes back through guardrails out. It checks contextual grounding to check it's not hallucinating, and then goes out to the user. But what about a more complex case? So I'm thinking like, can I get a refund in the case of delay? So I'm just going to repeat that. Can I get a refund in the case of a delay? Not just a refund, not a refund necessarily in the future, not a refund now, but in this specific case. So this is quite complex from a reasoning point of view, because actually the agent needs to understand this is kind of for the future in a specific case. So we go through to the supervisor. Now the supervisor would probably in this case first check the terms and conditions tool. Now in the case of delay repay, it's actually kind of a national policy. So it probably won't find anything in the T's and C's specific to it. So when it comes back, it needs to rethink, and it could go to a refund tool, but actually they're not asking for a refund now. So they're asking for this information, so it's going to go into the information retrieval tool. And what this is an LLM in itself that has access to a vector database. It'll do some RAG, bring back the answer, that come back to the supervisor. Supervisor might rework it a little bit, depending on the context, wider context of the question. Then it goes into guardrails out, goes back to the user. So we built this, believe it or not, in 5 months. We've now rolled it out, as I said, to 2 million customers. It'll be live to 100% of iOS users in the UK next week. So if you want to test it out, feel free. What did we learn from this so far? So in the A/B test, actually, we found that 7 in 8 queries are handled autonomously by the assistant. So this could be anything from a refund to T's and C's check. We've recently also added in the capability for real time. It can now tell you what platform you're on, can talk about delays and whether things to trains are going to catch up, can do all this stuff. And when it's out of its depth, it hands over to a human, but we're only seeing that happen 1 in 8 times. The customer can also ask to speak to a human. And again, we're only seeing that in a small proportion of instances. Second thing I would say we've kind of learned from this is actually building this kind of system is very, very hard. As we've seen probably in earlier talks today, the question is, do I add this to the prompt? Do I add a new agent? Do I add a new tool for this new capability? It's really, really hard. What I would say though, is if you do this carefully, you plan up front, you really think carefully about the principles you want to stick to when building these types of systems, you can do it. We did it, so you guys can do it too. Now, 2 final points to leave you with. Think about evaluation up front, and then always consider the dev speed versus equality versus extendability. It's very easy now to get a simple RAG system out to customers very, very quickly. But if you do that, you might leave yourself in a place where you don't have the foundations to move faster in the future. So what I would say is think about what that MVP should be, or should it be a minimal lovable product? So that's everything. Thanks so much for sticking around. Thanks so much for listening. Hope you enjoy the drinks. We're going to stick around for a few minutes. I think Diana wants to say one last thing before we go, though. There we go.
Please. Thank you, everyone, for sticking around till the end, and enjoy the rest of the day. Yeah. Thank you.